CI/CD. Okay. Most of us have seen CI/CD, but some of us may not have seen what exactly is a CI/CD. Okay. So what is a continuous integration, which we call CI in a CI/CD, is basically when we push our changes to a particular repository. So the repository related concept I'll tell you. But when we are pushing something, we have made some changes and then we are putting into one of the repositories. That's what we mean by continuous integration. And what is a continuous deployment is, once we have pushed our latest code, we have to deploy those changes in any of the environments. So as we know, currently we are having three environments. We have dev, test, and UAT. Dev, test, and prod. Okay. So uh, on these three environments, uh, whenever we push a code, so what we'll usually do is we'll push our code on dev, and then we will deploy it on the development environment, all of our packages. Okay, so the continuous deployment basically means the whole package of our code is deployed um, onto that particular environment. Now, currently we don't have any concept as a whole deployment on dev. Whatever we make changes to, immediately those changes get reflected in a job, and then we run the job, and then we can see the results immediately. But that is not the same case with our UAT environment or our production environment. All the changes which we put there, we also need to deploy them. Okay, so I'll come to that part. So, but before going to that, these are the basic terms, what we called as a CI/CD, right? So continuous integration is where we actually check in our code basically, and continuous deployment is the process of putting all those deployed code into a package and then deploying it on a particular environment. That's what we call the CI/CD. Okay. Now Git, what is basically is Git? Git is nothing but a repository structure. Okay, so Git is a provider which provides us to create our repositories. Repository is nothing but a folder. Okay, we have a local folder in our systems, right? Similarly, we are creating a folder on Git, and the GitHub is the platform for that. Once we create a folder, it's not like our normal local folder. It creates versioning of its own. So say I have created a folder for dev related code on Git, and I have put some changes into it. So the folder, as soon as I put some changes, each file in the folder will have a version of its own. It will show me what was the previous version, over and above that, what is the latest. Okay. And as we have Git, we can also, like multiple team members, um, they can collaborate together on Git. So when we have a repo access for the whole team, we will be able to push our changes into the same repository, and those changes will be reflected into repository. Also, it will have the older versions of it, the same file. Okay, so say I have one notebook, I have made some changes in that notebook and I have pushed that code. So that particular file in that particular repository in Git will have both the versions available. Okay, from the moment the file is created, it will keep the versions of it. Okay, so basically that's how the collaboration works using Git. So anyone can go and change that file, but all the versions will be kept. Okay, and another part here is branching and merging. Branching is basically a stream of a particular code base which we can use. So say I have a stable main branch for all of our package notebooks and all of our say DDLs. Okay, and I want to create another branch to work on. I don't want to touch my main branch on Git. Okay, so at that time what will happen is I'll be creating a separate branch for it, and I'll make changes to that branch. I'll validate that branch if it's working fine, and then I'll merge that branch into main branch. Using this, what will happen is I'll have a separate copy of my changes in a branch. Branch is nothing but it's a copy of that folder. Okay, altogether cloned folder in a copy, and there I'm making changes rather than directly changing anything in the main branch. Okay, and most of the policies for Git are, if you are merging a branch which has been changed, it needs to be approved by at least one or two people. Okay, that's what we call the pull request and pull request approval. So I'll get to that concept later, but pull request is nothing but merging of a branch into our main branch. So when we merge into our main branch, we need to create a pull request. That pull request needs to be reviewed by a peer and then approve it. Only when it's approved, it will get merged into our main branch. It makes the PR makes sure that all of our code is as per the standards, and it's not going to break any deployment, because deployment will come after our merge has been happened with the main branch. Okay, so these are some of the keywords or some of the concepts in the Git. Okay, and yeah, as I said, GitHub is the cloud-based platform which provides us all of these facilities. Yeah, concepts. So yeah, all the concepts which we have just discussed. So fork currently we don't have to worry about, but basically it's a copy of the whole repository itself. It's not a copy of a particular folder in a repository. Okay, repository you can consider it as a whole system. Okay, inside which folders have been created. But if you are creating a fork, you will create another clone of the system itself. Okay, a repository itself will be cloned for your own work. That is what we call a fork, but it's not needed in our case. Okay, clone is nothing but downloading um, a particular folder, okay, or a particular whole repository itself to your local folder to make some changes and use it into VS Code and then make some changes. So we basically use VS Code for our development and branching and then pushing up all of our changes. Okay, branch is as we have discussed. Okay, we have to create branch. Branch is nothing but a copy of the folder inside a repository so that our changes can be put into those folders to be merged into our main folder. Okay, commit is basically we are committing our changes and creating a local version of it, of our committed changes. It's not been pushed to the branch, but it will be stored in our local. But as soon as we push it, it will be pushed to our branch. Okay, so commit and push are two completely different concepts. Commit will save our changes into our local. Push will actually upload our changes to our branch. Okay. Pull request. Pull request is nothing as we have discussed. It's basically a merge request from our any local branch to our main branch. Okay. And merge is the process through which our local branch gets merged with our main branch. So there could be multiple issues during merge. That's why we are creating a local branch, so that we shouldn't go and do a direct um, push into our main branch. So merge will give us merge conflicts. You might have heard this term, merge conflict. It basically um, a conflict when the same file has been touched by multiple people, and it's none of it has been properly merged into main branch. So it will ask us which part of this we need to push into our main branch. Okay. So these are all concepts, but I'll show you how exactly all of this is going to look like. Okay. Yeah, there is one more concept in GitHub. It is what we call as GitHub Actions. Okay, so actions are basically a workflow which can be kind of a shell script. Okay, which will run and automate all of the tasks related to GitHub. It can check out a branch. It can do a merge into a branch. Then it can deploy an asset bundle. Through asset bundle is through which we are deploying all of our Databricks related packages like our notebooks and DLLs. It basically gets converted into a bundle and then it gets pushed to our environments. So GitHub Action is basically what supporting deployment of a bundle. It's a shell script. It will take um, all the required secret. Secret is um, basically um, a unique code which is needed for deploying into any environment. Okay, so it will take a secret, it will check out a branch, it will push into a branch, it will do a proper comparison, it will take the files which have been changed and then it will run it sequentially. Okay, and all of this we have written. Like what we want to do, we can write in a shell script and then we can do it. So actions are basically going to help us in that. Okay? I'll also show you how what actions we have written on our side. Okay, so integration with Databricks, how it is currently available. Okay, so we have a Visual Code Studio Code setup on our local, and we make our changes into Visual Studio Code. So whatever changes which we have done in Databricks, we can pull those changes into our Visual Code, and then we can push it to GitHub. Okay, once we have push it to GitHub, as soon as it's pushed to GitHub, um, our CD process will start. It's a continuous deployment process. It will our GitHub action will come into picture. GitHub action will get all the code which has been pushed to GitHub, and using that code, it will deploy the bundle, and also it will deploy all the DLLs around it to Databricks. So this is basically the proper flow of it. So from Visual Studio Code, a developer will push changes to repo, and using repo, we will do a GitHub action. A GitHub action will deploy all the dependencies into Databricks. Okay. We aren't running any jobs through GitHub Actions at the moment because we need the full control of our jobs. Even the smallest part of the job, we need to have control over it. That's why we are not running it through GitHub Action. But till the deployment part, we have written GitHub Actions. Okay. Yeah, and how it's done on our side. Okay. How the CI/CD has been implemented on customer engagement side. So we are doing CI/CD using a concept called Databricks Asset Bundle. Now the name has been updated something to, I think, distributed asset bundle, something like that. But it's called it's an asset bundle is nothing but a bundle of configurations which will take all of our resources. That's what we can call. Our notebook is our resource, then our detail file is our resource, our job YAML is a resource. Okay, it will put it um, together, and the configuration will be written into a single file which we called as database.yaml file, and then it will deploy. Okay, it will deploy to any environment which we say it to. Okay, so currently we are having three environments: development, test, and production. All of this out of this, test and production are configured for Databricks Asset Bundle, but development hasn't been configured because development is a bit scattered in our case. Each person has written their own notebooks into their own workspace. But eventually, when we migrate even the dev data to an asset bundle, then our changing a code into our own notebook won't help it to be deployed to a job. Okay, it will then need to be deployed. The whole bundle will need to be deployed on dev. Then only your job will support that notebook. So basically, the job won't be reflecting a notebook which is stored in your personal workspace. Okay, it will be through a proper service principal itself. Yeah, coming to the concept of service principal. Okay, um, our packages contain like notebooks, jobs, and DDLs. Okay, a service principal is a role which will have which is not an individual user. Okay, it's kind of a higher role which will have access to all of these resources, and then it can work on its own. So we have service principal set up for all of our environments. We have a service principal for dev, test, and prod. And using service principal itself, all of our job runs on test and prod. On dev, we are currently haven't set up, but on test and prod, it's using service principal. So no single user can do anything. Okay, everything will happen to service principal itself. Single user even doesn't have a permission to drop a table or drop a view. Okay, it needs to be done through service principal only. Okay, so that the service principal is what you can consider is an entity which is having it will have all the access. Okay. Okay. Yeah, as I said, so CI/CD in using our asset bundles is basically the implementation is done using service principal for each of the environment. Okay. Dev also has a service principal, but currently it's not implemented on Dev. We'll try to implement it on Dev eventually. Okay. Uh, each job is having a separate job.yaml file. Okay. To make them configurable. And environment variables are used to pass. Okay, all of these things I think it's better to be explained in through visual code only. Okay, so let me start with the visual code first. Okay, this is a test environment. We don't have anything set up on Dev. Okay, but I'll tell you how exactly it works on test at the moment, because whatever we do, we currently pull the data from Dev and then only we push it to test. Okay. So there are a few factors to be considered in Visual Studio Code. First is the repo. Okay, repository. This is our test repository. We also have one repository for production. Okay, so if I check out our production repository, it will be having a complete different set of check-ins. So this is a check-in graph where we can see what changes were pushed to production. Okay, as soon as I change it to test, this particular folder is going to pull the data for test. Now you can see it's completely changed. Okay, it's now showing me what we have pushed in test at the moment. Okay, so how a repository looks like. We are currently on GitHub. Under AZU commercial IT, we are having one repository, CM-IMX CE-DBX. Okay, this repository is our main repository. It handles all the code which has been pushed to test and prod. Okay, it also has one folder as for dev. It's a branch basically for the dev. So, but our main use for this repository is for test and prod at the moment. But you can see, right, there are multiple branches here. So each branch will be showing you different timeline of that particular code. Okay.